Right, everyone. Let's do the module page 16 first. Right. Uh, okay, this is Kelantan 2024. And I tell you, actually not hard to score physics as long as you do the question and you will find out actually some sort of question. They always ask the same thing. Then you will find out, okay, first question I cannot do, but it's okay. Once I learn, second question, but same type I can solve. Okay? Right now, this is a continuous current motor rotating in a magnetic field producing a catapult field. Now, do I still remember what is catapult field? Can please type. If you cannot, can you please refer back your book, your textbook, or here? What is a catapult field? Okay. Oh yeah, I'm so sorry. I think. Oh yeah, last time I didn't. Huh?
Resultant magnetic field produced by the interaction between magnetic field from a current carrying conductor and the magnetic field from a permanent magnet.
By the way, without reading, can you recall it? Yeah, I think I last time didn't teach you how to memorize yet. Actually, the definition is a really difficult thing for me. Definition. Yeah, got your book closed. Very good. Good. Got your book closed. Okay, so actually, last time I think I didn't tell. We just directly draw the pattern. Uh, uh, it's over here. So catapult field is SPM 2021. They really ask. Bahagian B or bahagian C, I mean the essay. Catapult field is a resultant magnetic field produced by the interaction between the magnetic field from a current carrying conductor and the magnetic field from a permanent magnet. Okay. So how to remember it? Okay, actually it's like this. Yeah, thank you, Jinhui. Catapult. By the way, we need to what to say that we need to understand first what is the meaning of catapult. I better write here. Okay. Yeah. Oh, I think I teach. I taught. Just I didn't write here. Okay. So taught 14. Okay. So now catapult field is the. Now you all write already. If not, like I explain 3 minutes, you start to write. Okay. Okay. First of all, what is catapult? Catapult actually means a force. Catapult, uh, catapult means a force. I think all of you know what is catapult. Not all of you. Catapult. Now this is the device. This is the device for catapult. Means it will produce a force catapult out. Yeah, I think that day outreach program, everyone already know the catapult field. Participant can chat with host only. Thank you very much. Okay, so catapult means there is a force of catapult force. And I believe all of you know field is an area. So as long as they say field means inside on a force. So catapult field actually means the area of catapult force is a resultant result of magnetic field produced by the interaction between. Okay, so you can see here got three magnetic field. Magnetic field 1, magnetic field 2, magnetic field 3. For me, every time when I want to memorize a definition, if you ask me to memorize in a sentence, I cannot. I need to analyze and I need to have the diagram on my mind. So you also need to do that. And remember, check N. I tell you definition, got a lot of N. Okay, so actually this is the resultant magnetic field. The result the results. Okay, the results. So result from what? Result from two magnetic field. Two magnetic field. Okay, so these two magnetic field, what they do? They interact to each other. These two magnetic field came from where? Like if we look at textbook, now, so here got two magnetic field. This is original field. Permanent magnet is a straight one. That day outreach we got. Thanks for Jia Hong and thanks for Alamak. Sorry, I forgot your name. Thanks for two of you. Your friend showed you already. Why suddenly the Ashton. So that why when they on the current on the power supply, then only the rod, the copper rod move. Because when we on power supply means there is current, then only these things got magnet. So this magnet, we call it as electromagnet. Means got current, got magnet. No current, no magnet. We call this the rod. That day the rod is a temporary magnet. Means got electric, got magnet. No electric, no magnet. So the interaction is permanent magnet and this one. This is electromagnet. But here what they say the magnetic field from a current carrying conductor, okay, we ignore first, and the magnetic field from a permanent magnet. Permanent magnet is That day you see the U-shaped magnet now. Okay, then what is current carrying conductor? When you see current carrying conductor, I'll call it a CCC. Means conductor got current, means it will turn into electromagnet. Means it will turn into, we also can call it as temporary magnet. Okay, so it's like number 2 plus number 3 equals to number 1. Okay, but not only plus lah, we call it as interaction. So number 2 is the copper rod. Number 3 is the permanent magnet, north-south. So when they join together, move. Because the two force, they act together, cause catapult force. Okay, so now can memorize already, right? What is catapult field? Catapult field. It is the you always repeat, it is catapult field is the resultant magnetic field produced by interaction between magnetic field of CCC, current carrying conductor, and the magnetic field of a permanent magnet. Get the idea already, right? Good. Like, now please write here without referring, right? We say that this the catapult, it is the resultant first magnetic field. Magnetic field. It is the resultant magnetic field produced by Uriah. This is number 1. Then you got free magnetic field. Plus means the interaction. So it's yeah, congratulations, Chris. You're all right in your book. I consider you all really know already, huh? Permanent magnet, CCC. Okay, next. Look at this. Since this is south, this is north. This is south, this is north. Actually, they should draw like that. By the way, the magnet should be a curved magnet. Okay. Then we see from this side. So we will see how the current flows. Always check current direction. Current flows from here to here to here to here to here. We can see the current flows in many ways because of the wire many ways. But we don't care other way. Remember, we don't care here. We just care about the current inside go inside the paper. Okay, so now we put a circle here. Go inside, right? So this is this one. The current direction we count in this way. Y dot and Y cross. If our eyes is here, we will see the current flow towards us means a dot. You don't, okay, when you find the book or some source, YouTube or what, they will say, oh, current flow out, current flow in. Up means up from paper, but I feel it's confusing for you. You just think about to you, a dot. If your eyes is here and then they flow away from you across, okay, that's it. Your eye, okay. So now this one, tell me this part go in should be a cross or should be a dot. Right, fast. Dot or cross. This way current in your eye is here, dot or cross. 谢谢烟少，谢谢 Chris. Yeah, it's cross. Then the current flows back towards you this way this side. This is your eye. So go towards you. What should you see? A dot or a cross? Thank you, a dot. Thank you. Yeah, thank you, Chloe. Also, thank you, Yan Shao. Yeah, see, cross and dot. And last time we remember, right? So which one is clockwise? Which one is anti-clockwise? So this is a cross. So this is a dot. So if cross clockwise, okay, means this is 9 o'clock, this is 3 o'clock. So the magnetic field will go down and go up 3 to 9. Yes, good. So since CC cross clockwise, so dot is anti-clockwise. Right, so let's draw here. This one is clockwise, 3 o'clock, 9 o'clock. So here got many clock, 1 clock, 2 clock. The third clock is how the motor flip. Okay. Then this one dot will be anti-clockwise. So if you are not sure, you just treat these things, this wire as a clock. 9 o'clock, 3 o'clock. Anti means 9 go down, 3 go up lah. Terbalik lah. Okay, so go down and go up. Okay. Then now, right, let's draw this. How? We start from center. As I said, this is a roundabout, right? Roundabout. So if there is a car come from left, let's say that north to south. So anti-clockwise. So you can do this first. You can practice first. The car will come from north to hit the roundabout and turn in this way. But of course, we don't draw directly hit the roundabout. Means it will be pulled up. So we draw a nice way. We rub this off. we draw a nicer way. The car will flow up and down. Like that. So if got another car down here, also it will go up and go down and don't touch here. Then this one, no way already. It's okay. We do like this. So here more force, here more magnetic flux, here got more magnetic field, here less. It will create a force down. Okay, so same thing here. Now, more challenging. Why? Because now the car, you treat the magnetic flux like a car. From north to south, from here to here. You need to pass by two roundabout. So you can check in a pencil first, draw it lighter. North hit the roundabout, go up and go down. Yeah, of course. Then you can see this one also go down, right? So then go down, then you connect. You draw first, you draw first. Then it will go up and go back. But of course, this is a draft. Don't draw like this. We draw like this. Why we need to have draft first? We need to know go up or go down first, the magnetic field line. So it will go up first. Then you can see center both go down. Both go down. So make sure you go center lah. Center, agak-agak the center. Why? Later we can draw other line inside. Then you make some width in between here and here. You make some width in between here and here. Okay. Then rub off the reference line. So then don't forget arrow. Okay, then let's draw another two car here. We may draw, we always start from center first. Then this one go up, then go down, and follow back here. Then this one go up and down, then follow back here. Okay. Then we add, so see, 5 lines is better. The center 3 first, then we add 2 at the side. Then this one go up, down, come back. This one follow up, down, come back. Can see that? So you can see here got more line. Here got less line. So there will be a catapult field. So catapult field, catapult force go down. The force go down. So interaction means the line from north to south, supposingly straight. But now got 2 roundabout kacau. This 2 roundabout is the CCC. All of these are CCC, current carrying conductor. So now they both become a temporary magnet already. Okay, then now we check here. Here more line, right? More line. Here less line. So more line, more magnetic field line will push to less magnetic field line place. So this is force. So just now I say got 3 clocks. 1 is CCC, 2 also CCC. The 3rd is what? 3rd is the rotating. rotating. So since this one moved down already, then later it will be here. This one moves up like that. Then they continue move flow. So the rotating direction is, you can make a conclusion that you put the F up, you put the F down. Then you treat this is a clock. This is 9 o'clock, this is 3 o'clock. 3 o'clock go down, 9 o'clock go up. Congratulations. The rotating direction will be clockwise. Rotating. Just now, what is this? This is magnetic field direction. So got 1 clock, 2 clocks, and the 3 clock is, the third clock is rotating direction. Can why odd number? Because if you draw 6 lines, let me find an example for you. Wait a minute. Form 5. Let me find an example. Okay, where is my example? Where is my example? Okay, I draw for you. This is, let's say this is north, this is south. This is one only. This is one only. So this one should go up here. 1, 2, 3, 4. Yeah. Okay, 6, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. It might have this problem now. 3 on top, 3 at the bottom, then you're confused. If odd number, 5, normally you will see 3 up, 2 down, or 3 down, 2 up. If you got 6 even number, it may be 3 on top, 3 bottom, then of course you can use Fleming left hand rules to show it, but you didn't show the difference of the magnetic line up and down. Yes, you must show where will it go? Actually, it will go down. But if you show 3 line up, 3 line down, we can't see the difference. If 3 line up, 2 line down, we can see 3 more than 2. Then it will push down. Yes, to show where is the force. Teacher, how do you get the direction of where the force should point? Nah, see here. Very good. You ask. Yeah, good. Ask question, huh? Right, so this one got 1, 2, 3, 4. Here got 4. Here got 1 on me. 4 minus 1, 3. 3 going to where? Going to downwards. Right here. 1, 2, 3, 4. 4 lines up, 1 line down. So 4 minus 1, more line to less line. So it will push upwards. Get the idea? That's why I wish you all control 5 lines, start from the center. Then you add 2 more lines in between, up and down. Finally, you add 2 more lines from very end to very end. This one, 2 marks. Good. Then, Fleming left-hand rules. Normally, if they ask you to show direction, it's 1 mark lah. But if drawing, 2 marks. And somehow at that day, you all haven't seen the Fleming left-hand rule set yet. I explained online, you also cannot understand one. So I guide you all know how to draw this first. Okay, then next. How to get 2 marks. The first mark is, actually this one's supposed to be 3 marks, but sometimes they can make different. Mark 1 is direction correct. From north to south, your direction correct. Second is your pattern correct. Must be the dot one here, for this case only, must be 1, 2, 3, 4. Up got more magnetic field line than bottom. This side, up less than the bottom one. Okay, Ken? Okay, you think like this. Here got 4 people. Here got 1 people. They push to each other. Who will win? 4 people push to 1 people. This one lost, so finally the force goes down. Can Yeah, the 4 people push to 1 people. 1 people against. Sorry, the 1 people cannot resist. 4 people push to the side. Okay, so this one So we can fill up here also. And then the first diagram very important. Don't think that, oh, I draw it here already. I know it see here. This one is 3D. So like this one go down. Sorry, go up or go down. Oh, sorry, this one go up. This one go up. This one go down. The force. So if we see from this side how it rotates, this is 9 o'clock, this is 3 o'clock. Okay, go anti-clockwise rotation. Sorry, clockwise rotation. Okay, trust me, when I first learned this, I struggled a lot, like you all. Okay, or maybe some of you will say, did you not struggle? For me, easy only. Then very good. So I try to guide you all, like guiding the younger version me. Okay, so now next. So now you're all okay. So you all try some other draw the field one. Here got many. Okay, so now next how. Like this is the portable device that can function as a screw or drill drivers tries to rotate at a low speed when turning the screw. Rotate key is rotate. Some more, a device like this move means this is a motor. A motor means inside got these things. Okay? A motor means so in your mind, think about motor. You need to relate back to what you learned. What is the physics concept about motor? Yes, first Fleming's left hand rule. Second is what? Second is catapult field. I believe now your mind already got the words right. Got three magnetic field. So catapult field is the resultant magnetic field from the interaction of magnetic field of CCC and magnetic field of permanent magnet. CCC is a temporary magnet, current carrying conductor. That's all. This is normally what they ask. Right now, next. Suggest the modification can be made to increase the rotation speed. This one low speed, this one increase rotation speed. But from my experience, if I want, I think increase the rotation speed means you can have high rotation speed. You also can have low rotation speed. But when I use this, too high speed, oh, the screw cannot muscle. Finally, I need to use manually. I rotate slowly. But it shortened my time can from this long become this short very fast. The last part I manual Okay, when used to drill holes in wall, for walls, yes, we need high speed more effectively based on the aspect. Okay, so now rotating speed. See, This question doesn't tell you anything about magnetic field. So many students will say what? Number of turns of coil should be more. Why? Can rotate faster. What do you think? Can or not? Accept or not? Right, in exam, okay, this one, numbers of turns, 1 mark. What do you think? This one can or not? Okay, right, one say yes. Right, fast. Yes. Right, quite. No, right, quite. Yes. Quite. No. Okay lah. Congratulations. Answer is no. That's why you all need to highlight this. Rotation speed, rotate faster. You are actually repeating the question. Not saying cannot is correct. Yeah, rotate faster. But what is this subject? Physics. So your reason, please relate it back to our physics concept. That's why when you first read the question, you don't directly go down. You think back the physics concept first here. Motto, Fleming's left-hand rules. Catapilt field got resultant magnetic field from the interaction of magnetic field of CCC and magnetic field of permanent magnet. They want you to tell how is the magnetic field. Understand? Yes, common sense, rotate faster. I would say this is a common sense answer. This is a common sense answer. Okay? But they want you to tell physics. So more number of turns actually can produce more magnetic field. The coil, that day we see one copper rod only ma. So the magnetic field not strong, but if we make it in a coil, see, so many coils, so many current. This one current one only. This one the current you can see so much. So more magnetic field lah. Let me show you some video. Understand? This is physics. Give physics reason. Oh, okay. Actually, that day, Jia Hong, actually, we want this effect lah, but sorry lah, cannot get. We want this effect. You all see, actually, we want this effect, but cannot get. You know why? First is look at their battery, so big. This one current very high. Second, look at this magnet, so huge, you know. So huge. And some more, this is magnetron. This is a neodymium magnet. Very, very strong magnetic field. Uh, see, see, really move to this side on. Then see, change direction, change. Okay. See, change direction of current like that day, Jahong and Ashton show lah. See, we want this effect, but the magnet not strong. Okay, so how to show? Where is my magnetic field? Hey, wait, what happened? Hello, add on already. Wait, what happened? Connection problem again. Is it? This is transformer, and this one. So when the current flow inside, then we got magnetic field. The magnetic field is a chrome. The white color one is magnetic field. And see one more thing is it this? Yes. Okay, if you can't imagine it, if you can't imagine it, now see. When switch is on, a switch is off. Off means no current, no magnetic flux, magnetic field line, magnetic field line. You see that? Magnet. Got current. Got current. Now we say this is CCC. No current, we just say conductor. You may ask what is conductor? Conductor is wire. Conductor is wire. Okay. Got current, got magnetic field. No current, no magnetic field line. So why more numbers of turns? More numbers of turns produce more magnetic field. Okay. See, we read one more time. Our question. Diagram shows the function. Magnetic field? No. Suggest a modification. Magnetic field? No. Why? They want you to write lah. That's why when you see motor rotate is a motor. Fleming left hand rule, catapult field. Catapult field, magnetic field. So many people would ask, teacher, in exam my mind blank. Why blank? You didn't recall. You didn't recall your physics concept. How are you going to get the keywords to answer? But another thing is physics is easy to score because sometimes they accept common sense answer. But actually, you want the best answer would be you tell the concept magnetic field. Okay, like next, shape of the magnet should be curved. Why? This one is to produce. Actually, you're all right first. Radial magnetic field lines. Okay, normally if flat like this is north, this is south. The magnetic field lines. See, I put a line here, is straight. But if you make a curved one, north and south, then the line will be like this. It's curvy and it can mix like a radial. Radial means radius. Why we want to do that? Because the coil turn in a circle. See, the coil turn into a circle. So when the coil turn in a circle, a radial magnetic field line can interact in maximum rate. They can interact in maximum rate lah. Okay, so remember this. This one not stated in textbook. Called radial magnetic field lines. Okay, now type of coil string material. Coil string. I think it's translation. This is Kelantan paper. Dawai gegelong. Should say type of coil wire. Wire should be wire, not string. But it's okay lah. So next time if you feel the English weird a bit, you better read back the bahasa. Because now the DLP in Malaysia maybe 20% only. So 80% in bahasa. So when they built the question bank, they would use bahasa first, then only they translate to DLP. That's why you feel why the English weird one. I read back bahasa. That why actually is die. What can say string, but also can say wire. Yeah, so what do you think? Hello? Like type of coil, material coil. I think the question, the sentence really weird. Should say the type of material of the coil wire, something like. Yes, copper, good, copper, good. Why copper? Like from chapter 3, like. Yeah, low resistance. Yep, good. So please write the really confidence one. Look at number 1, and you can add a few more. Low resistance, more current flow. Why more current flows? More magnetic field lines. The consequences, can see that. We want more magnetic field lines. Means we must have more current flow. How? Low resistance. But of course, the direct one is copper, low resistance. Constantly can. Very good. Constant. Very high resistance. And then I think that they outreach your friend told you that, oh, there are 6% there. Never mind. Your friend told you that this every time once you get the reading, you disconnect first. Disconnect. You off the switch first. Why? Because last year we got a case. One of my students gonna accidentally touch on conductor wire and very hot. It really gonna put because conductor wire high resistance. But the highest is what? This one cannot use here. So high resistance, we want to produce heat. So then the best is nichrome. So like our kettle, like our shower heater, that they all use nichrome wire. Highest resistance produce heat better and faster. Okay, only copper and aluminium is low lah. But aluminium not as good as copper lah. And then if got silver, like it best. So the resistance silver is the lowest, copper then aluminium. But the problem is now silver too expensive. So if you all want to buy computer or what, fast go buy lah, because the silver price increase, the computer become more expensive. Actually, our gadget inside got a lot of silver, but copper cheaper. So they want to make the cost and effect balance. Okay, so next. So that's why they use copper, some copper. Then, but they really need low resistance, they put some silver there. By the way, the best wire lah, so far lah, the common best wire lah is copper lah. Okay. Okay, but in the what where? This one. This one we use too much. This wire too thick and too long. So they also mix some with aluminium. But this small bottle, we all use copper. Okay? So 羊毛长在羊身上 means 一分钱一分货 means why when you buy the electronic gadget, some expensive, some a little bit low price, the material they use different cost. But so far in our physics, we don't care cost first. We just want theory first. Okay. Right? This one. This is a transform. So I think MRSM 2024 number 11, page 30. Right, page 30. I think you all can do already, right? See, when you read the question, please recall what is the concept. Is it chapter 4? Concept number 1, concept number 2? Recall that. Then write down the key. 11.1, 11.2 shows the final position of copper rod affected by catapult field. And then question can use affected, but we cannot. Why cannot? Because affect doesn't say increase or decrease. We only can say increase, decrease, right? Now, catapult field, I believe now your mindset already got the key, right? Resultant magnetic field from the interaction of magnetic field of CCC and magnetic field of permanent magnet. Always recall it out. That's why you all need to memorize definition. Got keyword for you to write. Okay, right, next we can see 11.1 and 11.2. This is the final position. Means this is the initial. Then this one move this way. Then directly you can analyze first. This one, final position short. This one, final position long. You may say, teacher, this one easy lah. Short lah, long lah. But you don't forget your exam 2.5 hours. When you do number 11, your brain already tired. Right? So why not when you analyze one, you just write short, long first. Then see what's the difference between dry cell and dry cell. This one more dry cell. More dry cell. So what is this? This is A. A means ammeter. Ammeter measure what, everyone? Measure what, resistance, voltage, power, current, electric charge, magnetic field. Measure what? Thank you, Ethan. Thank you, Christopher. Yeah, measure current from the eye. Thank you. Yeah, eye. So this one, this eye is, you can see, that day we also see that the zero starts here. Then if you feel, teacher cannot see the number, you can see this one closer to zero. This one, the current is lower. Then this one away from zero. This one current is greater. Low. Then actually we can get conclusion already. We can get relationship already. More dry cell. Okay. Less dry cell. Low current. Short distance move. More dry cell, high current, more current, longer distance move. Then normally what they will ask. Yeah. Sure, they ask these things one. That's why you need to analyze the diagram. Don't just see only. Because your brain tired. Don't think it's stupid. You are just step by step analyzing and answering. Based on 11.1 and 11.2, compare the number of dry cells you see. See the angle of deflection of emitter pointer. Final position plot. See, compare 1, 2, 3. Do you underline in this way? 5 marks, normally 3 marks for compare. 3 marks for compare. So the number of dry cells used in 11.1 is less than. So 11.1 less than 11.2. Angle of deflection of the emitter pointer, 11.1 less than 11.2. By the way, in exam, don't write this only. Please write the whole sentence. Then you say this. Okay. If you just write 11.1 less than 11.2, 11.1 less than 11.2, directly wrong because we don't know your sequence. Okay, essay must write sentence. Final position 11.1 less than 11.2. Can? Okay, like relate the number of dry cell used. Okay, when you see relate, you must always look at n. So before n is A, after n is B. So we do what? Relate, normally we can say A increases, B increase or decrease lah. This is the relationship. So the number of dry cell used increases. A. B. The magnitude of electric current flows. B also increases. Now see, when they say relate, N is important. Amen. Then this is the 4 marks. Then deduce the relationship between the magnitude of electric current flow and the force produced. Many people would stuck here and say, did you deduce a conclusion? No, ignore them. Relate and relationship, the same thing. So this is the number 5. Look at N. In front of N is magnetic field of the electric current flow is B. So the force produced is C. So for this one, B increase, C increase. More current flow, more force produced. Then 5 marks in your hand. What's the key they don't use? Magnetic field. Catapilt field. Fleming's left-hand rule. They don't talk here. They sure talk after this. Like again, like motto. See magnet, see curve. See carbon brush, commutator, coil. Tell me what you need to recall now. What concept like phải then when you see motor rotate like concept phải then like physics concept right? Simply give me a few words. Right. Hello? You cannot repeat means hello? Catapult. Good. Catapult field. Fleming left-hand rules. Yes, inside catapult field got magnetic field. What is the coil? Coil is a conductor. Coil or wire coil. And then if you give current, then it will become CCC. Means current flows in conductor. Current carrying conductor means what kind of magnet is it? Permanent magnet? Yeah, it's a temporary magnet. Yep. This magnet, permanent magnet. And then they interact, they start to rotate. See, before you read the question, you analyze first. Right? Now, explain the working principle of DC electric motor. Catapilt field. Working principle. Catapilt field. Number one. You just say this catapult field. Number two, you explain what is it as a verb. Means. Then number four, you tell when DC flows in the coil. You may say, teacher, can I write DC, direct current? Yes, DC. It's international symbol, can write, yeah. Flows in the coil, comma, okay, or maybe you say this is number two first, and number three, what? It will produce catapult force. Or maybe number two, you tell the whole definition first. Then from your definition already tell what is catapult force, catapult field. So it will produce catapult force. Okay, then number four, you tell all of this commutator. What is commutator? Commutator is this arm. This arm. So finally, since it was force, so the commutator will start to rotate. Motor finally will move. How it moves, rotate. So if you cannot think the rest, at least DC flows in a coil, at least catapult field, at least you know definition, 2 to 3 marks. So I would want to say the 4 marks depends on question. Some question easy to score, some not. But if you know the concept, you write the concept, at least 1, 2 marks. Right, next, 11.4 shows DC motor. You okay? Okay. Okay. Right, next. Used to turn the tire. Oh, tires. Tires. Memutarkan taya sebuah kereta mainan elektrik on a toy car. Electric toy car. So if you feel the English weird a bit, most probably they make BM sentence translate to BI. Then you read back answer. Okay, so now is this one magnet coil. Okay, this one magnet inside, coil outside. Okay. And now suggest and modify that what can be done to the motor of the toy car so that it can move with greater speed, move faster. So how we, I don't like this kind of question. They didn't give enough information. They just show you coil and magnet. That also is enough lah. Then, right, how is the coil? So actually, you can make the table like this. Number one is characteristic. Okay, number two is I'll make it half. Carry. Okay, like this is modification. This is reason. Okay, number one is the coin. So how to get 10 marks? Means actually this question also good in another way is you just modify the coin magnet. So modification number for coin number one, copper wire. Number two, more numbers of turns. Number three, more numbers of turns, more foil. By the way, this is this one, no, is this. Yeah, so you can see, actually, when we study, yes, we just have one. This is commutator. We just have one wire when we study, but this one very weak, cannot turn. So what we do, we put more commutator. Commutator can see just now from one become two. But this one also not powerful enough. So what we do is we make more commutator. Finally, like this, more numbers of turns of coil and more commutator. Like number four, more commutator. Why? I think you all know that more resistance, more current flow. Okay. By the way, in this one, you all need to write full name now. AC, DC, it's SI unit. Yes, not SI unit. International use. Okay, this one you must write the full name. More number of turns of coil, more magnetic, more current flow, more magnetic flux, magnetic field line. More coil, same thing. More commutator, also the same thing. See, coil already we got four. What else? And next is magnet. Number two, magnet. Magnet. Like how is magnet? Stronger magnet lah. Why stronger magnet? More magnetic field. Then just now, what's the shape? Then what's the shape? If you don't know how to tell, you can draw. Yeah, curve magnet. Why curve magnet? Produce what? Produce what kind of magnetic field line? Yeah, radial magnetic field line. Okay, 1, 2, 3, 4, 5, and 6. I want to say not everything is accepted in schema, but now you actually got more than 5 modification already. Lah. And the marking scheme, not every year the same. Sometimes this year accept, another year not accept. Uh, it depends on the question also, but sometimes the question looks the same. They got a little bit different. That's why some schema they accept, some they don't. But at least you can write more than 5 or anything else I didn't mention, but you think okay. Like, yeah, I think that's it lah. Oh, again, see, same thing only. I would want to tell you chapter 4. The question no doesn't really change a lot. But let's say the rule to determine the direction of motion of flow AB. That day we all learned from Jia Hong and Ashton already. No? Fleming's left hand rule. But spelled wrongly cannot have Fleming. 1M Fleming's left hand rule. Okay. Now see, same thing only. You may not know what is it. This is called a simple motor. Now this is a simple motor. Actually, if you want, you can do it yourself. But I try not working. Maybe my hands-on skill not good. Now then finally it will be like this. Now you can see got current, it will rotate like that. You can try it home. But the problem is I cannot get this kind of wire. Last time lah, now I didn't. Okay. What I get copper wire is like this. And actually this very thin copper wire must be laminated. So now you understand lah. Actually it will move lah. Then same thing, see? Force on current carrying conductor in a magnetic field. Why they don't tell you the name so that you can write the name lor? I think you all know lah. Then this is a homopolar motor. Yeah, so same thing, it will rotate. It will rotate. This question is nicer easier for you all lah. See, type of dry cell, number 1, number of dry cell, number 2, magnet use, number 3, connection of dry cell, number 4, series. When they ask about connection, normally series, parallel. If got diode, forward bias, only diode. Reverse bias, characteristic of wire. That's why it's very easy for you lah. So most of the time, like just now, if they just mention coil and magnet, we normally write 2 only lah. But after that, you can continue lah, motor or what, battery or what, something like that. But since here mentioned 2, we modify 2. The major one is this 2. If you got time, you do all lah. But don't do that in trial. I'll die. I'll die. Don't do 2. Do 1 only. Then this is this one we talk about in next class lah. This is called electromagnetic induction. This is induction. We'll talk next time. Okay, that's all for today lah. By the way, after this, I'm going to discuss number 11 for mid-year one. So if you want to stay, you can stay and for another 20 minutes. If you don't want, you can go already lah. Okay? Bye. Thanks everyone. Bye.
Bye, guys.
Bye. Bye.